Hi everyone. Today we're going to talk about how to solve algebraic equations, the terminology related to it, how to manipulate the equation, and how to make sure that we wind up with the result that we're looking for. So first we need to talk about the vocabulary related to equations. So we learned previously that an expression is a group of terms, could be one term, could be multiple terms, separated by addition or subtraction, multiplication, division, really any operation we want. Now, an equation is when we take two expressions and we connect them with an equal sign. So every equation that we're ever going to deal with has to have an equal sign. Now, a formula is just a fancy type of an equation where it's got variables that represent real-world quantities. And then we're going to talk about when it says find the solution or solve, it means let's isolate a variable and write that variable in terms of numbers or letters, whatever we have. So when we solve an equation, if it says solve for the given variable, there's only one variable. We're going to use all of the steps we've ever learned to get the variable by itself. So looking at this problem, we can distribute, we can combine like terms, we can move all of the x's to one side. I like moving the smaller x's, so negative 3x is smaller, so I'm going to add 3x to both sides. And then I got to move the negative 23 over as well. So I add 3x to both sides, and I add 23 to both sides. And then to undo multiplication, I'm going to use division. So I divide both sides by 5. We already know how to do this. We just got to keep practicing it. We get x equals 6. So it's possible for us to get x equals 6, one solution, and that's great. Now here's another example. Solve for x. So I can do distributive property, and then I can subtract 2x on both sides. And then I get something weird. I get 6 equals 8. So in this case, if the variables all go away and the left side and the right side are not equal, we have this case where there's no value for x that I could ever put in that's going to work. If I graphed these, they'd be two parallel lines. They would never intersect. No x's are going to ever make the left side equal to the right side. Now another situation we could have is this equation, where once again we're going to solve for x. We're going to use distributive property, combine like terms. But this case, I get the left side and the right side are completely equal. They're the exact same. So in this case, no matter what I put in for x, both sides of the equation are always going to be equal, which means infinitely many solutions. X can be any fraction, decimal, whole number, positive, negative, any real number we want to put in there is going to work. On a graph, these two expressions would be the same exact line. So they'd overlap everywhere at every x value. So the three cases we had were no solution, infinitely many solutions, or the pretty frequent one solution where x is a value.